Perfect. So I think we're going to make a start. Welcome everyone to the Material Science Question and Answer panel. My name is Erin McNeill. I'm the Physics Outreach Officer at the University of Leeds, and we're hosting this as part of a week of Discover Materials activities. Discover Materials is a partnership between UK University, Material Science departments, and the Henry Royce Institute, and we're promoting material science and engineering as a discipline and showcasing all the wonderful career opportunities that come from studying this degree. For today's event, we have a few people here in the audience, which is great, and we're really looking forward to welcoming you and having all of your questions answered about studying material science and engineering. If you drop out for any reason because of internet issues, just use the same link to rejoin. And your camera and microphones, they won't work here. This is a webinar, so don't worry about appearing on screen. If you'd like to see what we've been up to over the past week, visit our website, discovermaterials.uk, and you can catch up on any missed events. There's YouTube stuff, there's resources, there's a ton of stuff that you can discover there. And we're recording today's session, and you'll be able to see it on our YouTube channel as well, which is also called Discover Materials. So earlier today we had Barney Jobson, who's a regular on BBC's The One Show, talk to us about materials found inside iPhones. And what we have next is a really great opportunity for you to ask anything MSc related, from studying at university to working in industry and finding your dream career. So please ask your questions in the control panel. There's a Q&A box, you just gotta click it. Once the answers come through, we'll try to answer as many as we can. And yeah, it'll be really great. And we hope you have get a lot out of this session. So I'm going to start by, just saying, there's a speaker view in your top corner. You can choose speaker view or you can choose gallery view, whatever floats your boat. So just choose the best one for you. So what I'm going to do is have our panel members introduce themselves. They're going to tell you who they are, where they work, or what they're doing now, and one really cool thing or memorable thing that they have from studying at university, whether it was material science or not. Anyway, so get your questions in the box, and I'm going to start first with Mark Coleman, because he's on the top of my list.
Hi everybody, thanks for the introduction. My name's Dr. Mark Coleman, and I'm from Swansea University in South Wales. And I teach first year material science, and my background is predominantly metallurgy. And I'm also the outreach coordinator and the first year admissions tutor for the department at Swansea. And my sort of research background and my area of expertise is in characterizing the structures of materials. So you might have seen with Marty today, maybe he was using like a microscope to show you different sort of components. So I go sort of even further down in scale. So I use scanning electron microscopes and even transmission electron microscopes to look at the microstructures and even the atomic structures of materials. So I predominantly do that with metals, but over the last sort of 3 to 5 years, I've started working with other colleagues and doing other cool stuff. So over the last couple of years, I've worked with volcanic ash sediment, so tens of thousands of year-old ice core samples. And recently, I've been looking at more sort of bio-inspired materials, so things like cuttlefish and marine shells and other sort of mollusks and things, which are pretty cool. But predominantly my main area of research, because Swansea has quite a close link with the steel industry, because we've got a Port Talbot steelworks like right next to us, I sort of gravitate back to the steel industry whenever I can.
Great, thanks, Mark. Okay, so next up for who you are, what you do, and your coolest memory from MSc will be Sarah Glanville. Sorry, Sarah.
Hi everyone. So I'm actually very luckily at work, as you can see. There's a scanning electron microscope behind me, and a Raman microscope made by the company that I work for, which is Renishaw PLC. We're a metrology and 3D metal printing company based in the southwest of England. We have got various sites across all of the UK, but I'm at the headquarters in a place called Wootton under Edge. I went to the University of Birmingham and I did my undergraduate in material science and sports science as a joint honours, which was quite an interesting combination, learning all sorts of things from metallurgy, polymers, especially foams, looking at, how, sports equipment, lots to do with fencing vests, trainers' shoes, all the way into like sort of, crystal structure, how materials are made, into ceramics, all the whole shebang. And I went on to do my PhD at Birmingham University in material science and corrosion. So I looked at how corrosion sites initiate and propagate through aluminium alloys, which you use in aerospace and in the airframes that you guys fly in every day. And I did quite clever things in the sense that I looked at things with CT. So the area that I specialize in now is computed tomography, specifically of, all sorts of things that we now do in the 3D printing world. I don't know why I've ended up here, but some of my expertise I learned during my degree. So SEMs, CT, and Raman as well, doing characterization, identification of different materials, has ended me in a job where my title is material scientist. It's quite a general term, but essentially I work solving problems, doing forensic science. So if something has broken or gone wrong, I backtrack, I look at the material's behavior, fracture surfaces, lots of things with contamination on them which have broken, and I put them in CT scanners and SEMs, and I try and find out the root cause behind those things and what happens. My highlight at uni was quite fun, actually. I had the opportunity to go to a place called Diamond Light Source, which is a synchrotron in the UK down in Didcot in Oxfordshire, as an undergraduate, which was very cool. And I shot very, very, very powerful X-rays at things and looked inside of them. So that's me.
Wow. Okay.
Yep, I do a lot of stuff. So.
I'm still stuck on the material science and sports science. I think that's so cool.
Yep.
We're going to talk about that later. Cool. Thanks, Sarah. Okay, next, Samuel. You're on screen now.
Hi, everyone. I'm Samuel, and I am a graduate materials engineer at Dyson. So my work is quite varied because we have a very small materials engineering team. So most of my work is around polymers and temperature materials for hair dryers and hair products. But also I do some work on ceramics and some metallurgy as well. I feel like at Dyson, you're sort of end up doing sort of like very different things. A lot of characterization work, a lot of commercial work as well, working with resin suppliers and sourcing new materials and so on. And also I did some biomaterial stuff as well, like understanding protein folding in hair and how can we retain style for longer and so on. And I think that was actually one of my favorite things at university. I had the chance to go back to university, and as part of my materials engineering degree at Loughborough, I was able to characterize the behavior of hair in regards to temperature. And like my project was actually finding out what's the best temperature for styling hair, which is not a typical material science project, but I actually really enjoyed it. I think it was quite different from most materials projects that were offered by the uni. So I really like that.
That's really cool. And I think we forget that material, like hair is a material, right? It's made out of stuff. That's the material. Pretty cool. That's really awesome. And really neat that that's what's behind a Dyson hairdryer. This is very exciting. I might go out and buy one now. Thank you, Samuel. Okay, so Belinda, how about you? Can you tell us about yourself?
Hi, everyone. So my name is Belinda. I'm a recent graduate from University of Birmingham. I just graduated last year. And since I graduated, I've been working at the European Space Agency in the Netherlands. So I'm actually in the Netherlands right now. And within ESA, as we call it for short, I work in a team called the Advanced Concepts Team, which is looking at future concepts which might be useful for space travel in the future. And specifically what I work on is materials for space habitats. So how we might use materials that we could find on the moon or on Mars to help us build a habitat or infrastructure that we would need to eventually have a long-term presence on other planets or on the moon. I'm just thinking about all of my standout moments from my degree. There are many, but the one that really does stand out is my memory from first year, the first time I witnessed a Sharpie impact test, which is one of the most fun experiments to do, measuring how much energy is absorbed by a sample when it fractures, basically by hitting it with a giant hammer, and it creates a great noise. So that's my one standout memory of many others from university.
Yeah, really cool. And I think what's great about materials, you get to make stuff, but you also get to break stuff, which is really cool.
Indeed.
Okay, thanks, Belinda. All right, Adrian, tell us about yourself.
Okay, good afternoon, everybody. So I did a degree in natural sciences at Cambridge and specialised in materials at the end. And then I went on and did a PhD, or DPhil, as it's called, in materials in University of Oxford, where I did electron microscopy of things related to carbon. But actually, my career changed after that. I did a little bit of work as a postdoc at the University of Surrey, and then I started with a tech spin-off company in Oxfordshire, near the Diamond Light Source, actually, before it was built, and got a taste for what it was like to be an entrepreneur. I was working with entrepreneurs at that point as an employee, but then I moved overseas to Singapore and worked for the Institute of Materials Research and Engineering, where I actually spun a company off in sort of nanotechnology and anti-counterfeiting technology. So then I spent a lot of time raising venture capital finance, selling materials-based products to new customers, and then took the company through to what we call an exit, where we sold it as well. Now I'm back in the UK, have been for a while. I live in Malvern. I have my own businesses here. I actually work with the University of Birmingham as a Royal Society entrepreneur in residence, helping other people that are interested in sort of entrepreneurship and commercializing technology. And one of the things I organize here is the Malvern Festival of Innovation every year. And in fact, Marty, who you've just heard from, kindly spoke at our festival last year. So yes, he's absolutely fantastic. And my highlight actually from my undergraduate, it's having to look back a long way actually to try and remember this, was actually a tour of Scunthorpe, the big steelworks there. And I was just amazed at how they were throwing very, very large ingots of steel around. It was quite a fascinating sight. Thank you.
That's great, thanks, Adrian. And you bring like such a cool perspective with raising VC money and doing spin outs and stuff, because that's a huge part of what we do in research, which I think is really cool. So yeah, great that you're here. Awesome. Okay, last but not least is Fiona. Fiona, please tell us about yourself.
Hi, thank you. So I'm a lecturer at Loughborough University in the Department of Materials. So I can say that I didn't necessarily do a materials science degree, but that was basically because I didn't really know it was a subject until later on. So I went to uni and studied chemistry, and then through after my PhD, that was in polymer science and postdoctoral work, I got to know materials as a subject. So that's I think one of the things that I go for my standout moment, as you said. I'll think about the time since I've been at Loughborough. I've been teaching on our foundation module that we have here, and it's kind of similar to what Belinda said, but you know, some of the materials testing that we do. So when we get the foundation students in the lab for the first time, they do some tensile testing of different samples. It's always quite interesting to see their reactions for the first time when they do the tensile test of different metal samples. So they're always quite shocked at the sound of that, the specimen breaking, which is always quite nice to do. Yeah, so I suppose my research interests are in polymer science. So most of this work that I've done has been designing and making new polymers with interesting applications, making the structures in particular ways that gives them specific properties that we want to take advantage of. So that's me.
That's great. And I think that really echoes like my own experience. I did a general first year of engineering and had no idea that materials engineering was a thing in high school. And so I'm so happy that I was able to find the degree, because I really liked it when I studied too. And just breaking stuff was the best. So I think we have a question come in. Mark said that he'd like to answer it live. So it was, how did you decide to this is for the general panel, but how did you decide on a material science degree or material science or engineering degree? And this person, Steph, is trying to decide between Chem-Eng and MSc, which is like a valid choice. And they're just trying to decide on any tips or have any tips from you guys about either or, basically. So if you'd like to, I think Mark's unmuted, but just, raise your hand and I'll call on you next.
Yeah, I think this was a great question from Steph, because I think this is quite a common theme, really. And amongst us as panelists, maybe everybody attending can kind of see that materials engineering isn't really well advertised. And it's one of the reasons why we're all here today, to try and sort of advertise it a bit more and push it more into the general public. And so people like Marty Jobson or Mark Miodovnik, they do some really great work in advertising it a bit more. In terms of deciding between Chem-Eng and materials science and engineering, I would say of the other engineering disciplines, I don't know whether this might be controversial or if you'll all agree with me, I think chemical engineering is probably quite close to materials science and engineering. But one thing I would say is that materials science and engineering has a bit more of a broad base of different avenues to sort of research. Maybe you've had a bit of a flavour of that today from us. I think both disciplines look at the chemistry of materials and the atomic structure of materials. But where materials science and engineering goes on and progresses from that is in the sort of more engineering side, in the sort of applied side. You look at things like how things have been applied now in European Space Agency materials and things like that. So it's quite a difficult one to answer, really. What are your thoughts on the panel, guys? I mean, in terms of differences between chemical engineering and materials science. I remember we did that. We did like a survey a month back of all our first year engineering students, and I think the majority of them were considering chemical engineering when they decided to take material science as well. So it's very, very common overlap between the two.
So I know that, so Sarah and Samuel both raised your hands. So Sarah, how about you go first, and then Samuel, you can answer second.
So I think thinking less about maybe research and more about industry here, as someone who's done a bit of both. We hire some chemical engineering students to this company, and it's quite interesting to see their place and where they fit in. Ultimately, Renishaw is like an engineering company. Material science has its kind of place here because, you can't make anything without us. You need our consult, you need our input from the basis of understanding. A lot of the chemical engineers that I know from undergraduate, maybe not so much if you go further afield and start to specialise, say in a PhD or further study as a postgraduate. There's a lot more emphasis in chemical engineering, very, very specifically in engineering, not necessarily science. So you're taught a lot of skills about how to solve a problem. You're not given the skills to solve any problem. If that makes sense at all, the whole engineering versus science outlook on things, the skill sets that you gather from both of those degrees might be quite variably orientated. So, a scientist, we can pull on a load of different strings and apply things in different areas, whereas I think, especially working in an engineering company, there's a certain way to do a thing, and you do the thing the way that it's been laid out to you, like a mathematical equation. You're not deriving them, you're following a sum kind of attitude. I think ultimately as well, I know a lot of chemical engineers work in very, very large industries, doing like gas scrubbers, working in very big teams and groups, like you're part of a puzzle piece. But you could say the same thing about material science. So I think have a little look at the industries that you could possibly work in at the end of those things. Chemical engineering could be things from the perfume industry all the way into, the chemical cleaning industry, oil and gas and that kind of thing. Whereas material science, I mean, you kind of fit in anywhere as long as there's a material kind of aspect to it or an angle. I don't know if the rest of the panel agree with that or not. It's engineering versus science for me.
Yeah, no, that's a great way to put it. Anything that's made of a material science or a materials engineer can tackle, which is great because like everything's made of materials, which is awesome. Okay, cool. And so Samuel, what did you want to add to the conversation? Sorry.
I completely agree with Sarah, first of all. I agree there is like much more of focus on engineering, but also there are a couple of other things I noticed about materials engineers versus chemical engineers from like previous companies I've worked at. I feel like with chemical engineering, there is like a big push on downstream development. So I feel like materials engineers tend to work across the entire product development all the way to production. Well, to my understanding, chemical engineers are more focused on the sort of like production scale up and like making like small things a lot of. So I think that is like the biggest focus of chemical engineering. And I think that's a big difference with materials, because materials is needed across the business. The other thing is, I've also noticed that chemical engineers tend to be more involved with like fluids rather than solids, which is something else that's, I think, is a big difference. We focus a lot on do the properties of the material match the application. Chemical engineers will focus more on like making a lot of like fluids, like oil and gas, or like conversion of these fluids into like plastics and so on, rather than the plastic itself and the quality of the plastic itself. I think those are other two big differences between the two courses.
Yeah, that's great. That's a really great way of summarizing that. Yeah. Thank you, Sam, very much. And I think there is a follow-up question to this about bioengineering. So Fiona, I noticed that you'd like to answer that one, so take it away.
Hi, thank you. Yeah, so I just saw that one and thought I might be able to comment on this. So we do offer bioengineering and normal materials courses, and I know quite a few of my personal tutees do the bioengineering program. And so in terms of the actual content, I think that there are some overlaps, because obviously bioengineering, you're looking at materials and maybe how they interact with the body. But I think in terms of bioengineering, you're also studying modules that are more biology focused. So I think there are some similarities and overlap. But I think within bioengineering, you do some materials science, but maybe not in as much depth as you might do if you took a material science and engineering course. So I don't know if that helps to answer your question, or if any other members of the panel could comment on this. I think it's not so much of it's a broader field. I think you've just got a different focus in there, but they're both good. I mean, the materials is interesting. So if you're interested in, one over the other, I don't know if you've got any more specific questions we might be able to answer. And there's also courses like biomaterials engineering, which might give you a bit more of a bio focus without going all the way over to bioengineering. So, yeah.
That's great, yeah. And there's always the opportunity to start quite general with material science, and then as you progress through the years, kind of pick and choose the courses that you find really interesting and really tailor the degree to your interests, because I'm sure when you come to university and if you study MSc, there's going to be a lot more out there than you even could have imagined. So yeah, tailoring it as you go along as well is a really good thing. So I see another one about talking about job listings, specifically asking for MSCs. And I know as an MSc grad, I felt when I looked for jobs, there was no one job that said material science engineer. And I found that a little bit like confusing, because I felt I had all of these skills to offer and all of this knowledge. How have people working in industry found that? Okay, sorry, go Sarah. I'm pointing at you on the screen. That didn't work.
I hope you meant me. So I graduated from my PhD about 2 years ago, and I actually found this to be not problematic, but I think if you went to a recruiter, for example, they also struggle with what a material science is. The way that I went about it is I kind of had a hit list of the type of industry I wanted to work in firsthand. And I think one of the reasons way back when I think about starting my degree, I started the degree because I knew I would have jobs in industry afterwards. Every single company needs a material scientist, no matter who they are. The only variable with actually searching and looking for jobs online is depending on the internal system that that company may use, you'll have different titles. The title that you have on a system, which is, how you go onto payroll, how your email address comes up internally with the company, they can range from all kinds of things from say development engineers to material scientists, project scientists, and all these kinds of things. But the best approach I can suggest, which I use, was find the companies you'd like to work for and just look through the jobs listings. The terminology of material science is quite difficult. I got lucky because my job title happens to also be material scientist. So when they put the job posting up, it was for a material scientist. But I mean, we've got other people who work, you know, girl who's next door to me, who's a materials technician, but she's still technically a material scientist. She's just the level below me in the grand pyramid scheme. That is how the company functions, which can be kind of annoying. But the best thing I could also advise is put in a prospectus CV. HR are always looking for people. The jobs might not necessarily have a title, so that can be another way of going about doing it. And have a think about what you ultimately want, where you want to work, location, industry, and there'll be material scientists. That's the best advice I could give.
No, that's fantastic. Thanks, Sarah. So I have a question now for Adrian. So Adrian, I'm really interested to hear more of this relationship between research and business and industry and how those two things link up. Because a lot of people wouldn't think that they work together, they function together. But could you tell us a little bit more about that and how it works?
Yeah, and I think it's a really important area, actually. So there's a lot of pressure now on academic research to have economic output, in other words, to bring benefit to society and commercialize what you're doing. And equally, there's a lot of encouragement for industry to work with universities to improve what they're developing and take on new innovations and so on. So my view is that, and in particular material science, there are a huge number of opportunities where I think you can go from academia to industry and industry back to academia during the course of your career. You know, in the past, people have often said, well, once you become an academic, it's very much you've got to stay there and work your way up through the university system. I think that's changing a lot at the moment. So because materials is so applied, there's so much work that can be done, and I think it adds to the excitement of your career. So, you know, you can, like I did, started in academia, I was writing papers, I was doing research that was very new in laboratories, and then later I spent time in industry where the work is more applied and has sort of more immediate impact, you know, on people using it around you and so forth. So I don't know whether that answered your question, but I think it's an area that's just going to increase in activity, that sort of bridge between academia and industry.
Yeah, no, that's great. That was a great answer to the question and showcasing how important it is to work together, both inside and outside of the university / academia. That's really cool. And so my next question is for Belinda, because I am just so obsessed about what you do at ESA, because it sounds so cool and like a movie. So please, can you tell us more about some cool stuff that you're doing and how you even landed a job at ESA? Because I can imagine it can be quite competitive.
Yeah, absolutely. I mean, as Sarah said about looking for jobs after you graduate, it is really important to just sort of go for the companies that you think sound interesting and sound exciting and relevant and see what they have. So that's actually what I did, is I went on the ESA's website and found the job listing, and the application was very competitive. I don't know the exact numbers, but I do have many colleagues who are on the same graduate scheme as me that had actually applied more than once. And it's just like any other graduate role, you interview a few times, and then I got the job. And so I'm working on a lot of projects. My job is very research based, which means I get to spend some time in the lab as well, which is nice. Particularly, I already mentioned the moon and Mars and the idea of habitats in space, and that's really what I focus on. And the key word here, or the key phrase, is in situ resource utilization, which is a fancy way of saying using what we have available to us in the place where we want to build. And in this case, it's lunar regolith, which is the moon dust or the Mars dust. And it involves a lot of taking information we have from say Apollo missions, taking information about the material that, because we have a very small amount of actual lunar material to look at, taking all of the information that the Apollo scientists have managed to glean from this very rare lunar dust and saying, okay, could we use this to do some 3D printing? Could we use this to make some sort of form of concrete? One particular project I'm working on is creating a form of concrete similar to concrete called a geopolymer, which is a silicate-based polymeric material. And the interesting thing about this type of moon concrete is that we found out that you can actually add urea to the mixture, and it really improves the recipe, and it decreases the viscosity of the uncured material. So hopefully we will eventually be able to 3D print with it. So that does actually mean, as you might have already guessed, that we could make use of astronaut urine to help us build habitats on the moon. So really crazy out there ideas, and it's been really exciting to work in a research center where you can, you know, have these crazy ideas and see where they lead you. So,
can I ask Belinda a question? Sorry
yes,
to like butt in. Was this something that you were involved in as part of your like third year dissertation project, or was this something like ongoing research that was going on in your department, or was this something like totally new that you did?
Yeah, that's a really good point actually. So I will admit I was completely not interested in space while I was doing my degree. My bachelor's and my master's dissertations were both on metallurgy. So moving to ESA and towards a more ceramic regolith topic is a complete change for me. Yeah, it was a bit scary for me to make that change because I'd worked a lot on metals in my degree, but I did have the basis from other courses I'd taken in the ceramics and the 3D printing and all these topics which I'm able to use now.
I just feel like I can't believe we're making concrete out of urine, which is like a great takeaway from today. Fantastic. Look at all this cool science we're doing. And that's literally going to be my fun fact for like the rest of the year. It's very exciting.
It's a great one. It's a great icebreaker story.
Yeah, no, it's fantastic. Thank you for contributing that. That was just like, we can like end this webinar right now. Okay, so I guess next we've had like a few questions coming in about maybe more so for the people who work in universities now about admissions, projects during the pandemic, what it's going to be like to study at university next year. Would Fiona or Mark, would you able just to chat a little bit about what's going to come very briefly, not too much depth?
Shall I go first, then Mark, you can take over or add in anything that I might have missed. So in terms of projects, obviously with the shutdown of labs and lockdown, it's been a little bit different from normal. But we're sort of, I think every university at the moment is looking at getting labs reopened and getting people back into the lab to do project work. And so obviously depending on what happens over the coming months, there hopefully will be the reintroduction of projects from next year, or maybe towards the later end of next year, depending on the university situation. So yeah, so things are a little bit different, but I think that, you know, we're all trying to work towards getting things back up and running and open again. And there are some situations, for instance, where we might not be able to get into the lab to do the synthetic work, but if you've got samples, you can still get those characterized and you can still have that data to analyze. And so the research is still going on. So yeah, so I do concede it. I mean, it's a bit difficult at the moment, but hopefully over the coming months, things ease up a bit and we can get those projects back off the ground again. I think I've probably forgotten half of the question there and answered half of it, but yeah.
That was great. Well, basically, yeah, what you said was we're taking it as it comes, things are opening up, we're still able to do our research. I think that's the most important thing to get across, that things are still happening here in the UK, which is great. Mark, would you like?
Yeah, can I just add? I think the point there that Fiona raised was that I think most of us chose material science and engineering as a discipline because we like making things and we like breaking things. So we actually like being in the lab. And so the big push is from most of the departments to keep labs available, either remotely, so sending your samples in, like Fiona said there, or to let samples come in and work, you know, via social distancing rules.
Can I just point out that Sarah's putting samples into stuff as
yeah, exactly. So there are ways of doing it, and I think it's one of the key things that, you know, we want to try and keep alive, because it's one of the sort of selling features of material science and engineering is to get in the labs. I like being in the labs, like what Sarah's doing now, in front of a microscope. That's where I feel most comfortable. And so the sort of second half of the question, just reading it there now, was how is this going to affect the admissions and international students? Obviously, next week is the sort of big week for clearing. If you get in touch with the universities via clearing or via the admissions tutors, like somebody like me, then we'll have lots of information for you. We are basically trying to adapt. Normally now we'd be looking at A-level results and then making offers and that kind of thing. So some of that hasn't really changed that much. So we're trying to keep it as similar as what it was last year. International students, I can only really talk about what we're trying to do at Swansea. Essentially what we're doing in the first semester is we're offering most of our teaching online, but we're also offering some socially distanced lectures as well. So if you are an international student and you do decide to move to the UK, so long as you sort of obey any, whatever the quarantine rules are at the time, because things are changing, as we know. It seems like weekly, but it's mostly daily at the moment. We're all trying to accommodate all sorts of students as well. So hopefully that hasn't discouraged you from coming to university, everyone.
Thanks, Mark. That's great. So talking about university, one of the things, so we know that we go to university to get a degree. That's number one. Number two is doing lots of cool other stuff. So would anyone like to share any extracurricular activities or sports or stuff that they did, and maybe how they balanced doing the other stuff other than your degree? So I'll go to Sarah first because she had her hand up, but would love to hear from everyone on the panel about that.
Yeah, sorry about me zipping around. I just thought the way that we're working at the moment, I have to be in here as minimally as possible. So I'm getting all of my data today, and then I have to work from home for 2 days a week. So
totally cool. It's awesome.
Around, I know. So when I was at university, there was a question on here as well about sports and extracurriculum. So I was actually a full-time athlete while I was at university. I was a TAST scholar, so a talented athlete scholarship scheme scholar for the sport of weightlifting. During my undergrad, well, the last year of my undergraduate mostly, and then all of my PhD, I was essentially training full-time during my PhD, which got a little bit hairy at times. But it's things that you need and skills that you need in your everyday life, which is just planning and organizational skills. I just took a 2-hour lunch break rather than a 1-hour lunch break, and then worked a little bit later in the evenings to fit things in. Ultimately, as long as my lab schedule and the times that I had to take my experiments in and out were acceptable to work around my training, eating food and all the rest of it, I fit in quite well. And the sort of social side of it then ended up happening because everyone I was training with were then sort of my collective of friends at university. I still had plenty of time for societies and all kinds of different non-sport activities as well, which was always nice for a bit of downtime during the week. But I guess you get up to as much trouble as you would feel you can whilst balancing your studies. Because at the end of the day, you're at university to get a degree, but there's such a vibrant culture at every university across the UK. You sort of do make friends for life there, and you should embrace that as well as doing your degree in the best place that you've picked, really. So just enjoy it and do what you can.
Yeah, no, that's fantastic. Would anyone else like to share the cool stuff that they got up to at university? Raise your hand. Cool. Belinda, go for it.
So that's really cool. I didn't know you did weightlifting, Sarah. That's really awesome. I also I actually joined a new sport while I was at university. I learned how to play rugby, which took up a lot of my time. Sport in general can take up a lot of time if you would like it to at university, and the social side of it is really amazing. I got involved in the sort of amateur theatre side at university, and some of my favorite times at university were getting involved actually in the Materials Society. And I can't speak for all university courses, but certainly the case on my course is that the materials department was maybe a little bit smaller than the other engineering departments. So the network that you have is really great for socializing and career activities and all these extra activities. And so I was really involved in our Materials Society as well.
Samuel, I saw a hand to the chin. Did you want to say anything? Oh, you're
just realized I was on mute. Sure. So similarly to Belinda, I was actually involved in our Material Society at Loughborough. As you can imagine, Loughborough is a very sporty uni, so I thought it's probably wise to pick up a sport while I'm there. So first year and second year, I started fencing for the first time. And I've got involved in a lot of other activities like volunteering, fundraising, and so on. I mean, it is possible to balance out your degree and social activities, and a lot of people do it. You just need to like not overload yourself. But I think that honestly, that's one of the best part of universities. You're not just there for the degree, you're there for like the whole experience, to meet new people, to do fun things that you wouldn't do elsewhere. Like many universities offer opportunity to go to places like Kilimanjaro on fundraising trips and so on. Like when you're at university, you really need to take advantage of these opportunities because you are unlikely to find them again after university. So I think that that's also a massive part of the university experience.
Great, yeah, and I think one of my teachers in high school told me, like, really embrace university because it's the last time you're going to be around so many young people the same age as you, all having a good time from places all over the world that you would have never met in everyday life. So yeah, so it's make connections, try stuff, have a go, all while keeping your studies on track. That's number one, of course. So we're starting to kind of wrap up a little bit, and I know that this could take a little bit of time, but I would really like to hear from each and every one of you what's one really cool thing in like material science that is upcoming. So like, is there something that's really cool in your research or something new that you're trying to find out in materials that you're really looking forward to, or that's kind of on the horizon that you're like, I can't wait until this is actually a thing? Would anyone like to start, or I'll just start picking on people? Okay, Samuel, go for it.
I think that the coolest thing coming up in materials is 4D materials. So I think that's one of the most exciting things. 4D materials are materials that are responsive to stimuli. So something that was quite interesting, there is some research going on at UCL at the moment where they're mixing plastics and metals in order to create plastics that respond to magnetism. And things like that. So I think that there is a 4D materials and and materials that respond to like different stimuli. I think is going to be one of the most exciting things coming up soon.
Again, 4D materials. That took me for a surprise, but very exciting. Thank you, Samuel. Would anyone else like to go next? Well, Mark, you're doing research. So
okay, I'll step in there. Yeah. So not to give too much away, but I'm currently working on a project with a student of mine who is looking at something called electrical steels, which I know it's a bit steely, but it's back to metallurgy. But it's all about getting the best sort of magnetic performance from steels and recycling these steels. And so if you think about the popularity now of electric vehicles across the world, really, you can't really move without seeing a Tesla on the road or a Renault Zoe these days. And so I think the electrification of transport is going to be a big, big step up. If we're all looking at some of the bigger problems that we have as a society in terms of our pollution, our reliance on fossil fuels, And the sustainability of some of these energy sources that we have, I think, is a big challenge. So I know it sounds a little bit boring to say, well, steel might be one of the solutions, but if you can get these steels to perform in a most efficient way, then you can get these high efficiency motors and you can go further with less energy. And so I'm actually currently working on that at the moment. So the second thing is battery technology. We have a department, we have a whole big group at Swansea University looking at turning buildings into power stations. So we have a group called Specific, and their remit is to store, generate and release energy during the day. So your home will be its own power station and its own battery. So I'll leave you with that.
Cool, two really cool things. I love it. Okay, so Belinda, we've already heard about concrete made from pea. Tell us something else that's cool that's coming our way.
Yeah, so the thing I'm most excited about is also space related, as you might have guessed. Obviously, I'm looking at, in my research, manufacturing and constructing on the moon, which has gravity, but there's also loads of potential for in-space manufacturing in a zero gravity environment. And you know, so this has really exciting potential because the space environment is so different to any lab conditions we can create on Earth. You get really extreme temperatures, you get a really perfect vacuum in space. It's far more perfect than any vacuum we can create on Earth. There's no gravitational or buoyancy effects. So in terms of alloying and metal casting, this has really exciting possibilities. So I think in-space manufacturing might not happen just yet, but eventually when it does come along, could create some really new, exciting materials with some really, you know, far out capabilities that we might not be able to create now.
Yeah, that's so cool. And as soon as you said, like, it's the perfect vacuum, I was like, oh man, obviously that's such a cool place to manufacture something that requires that. Really cool. Okay, Adrian, please tell us what you are looking forward to in the materials world.
Well, I think recycling actually and materials recovery is really important now. And obviously we hear a lot about the environment and the impact that materials like polymers are having on the environment. But I think as material scientists, we're really well placed to help solve the problem. And if you think about some of the materials we're making now, which are ever more complicated composites, where we've got lots of materials combined together. I mean, a silicon chip or a display like a TV or a computer monitor. These are really complicated composite materials containing lots of different stuff that we've got to learn how to extract and get back. And I think over the next few years, there's going to be a lot of investment in this. There's going to be a lot of opportunity for people that know their materials to contribute to this problem.
Great, thanks, Adrian. So we're going to do Fiona and then we'll finish with Sarah. So Fiona, go for it.
That was a good, yeah, no, good. I was going to say mine was quite similar to Adrian. So I agree with the recycling, and I think sort of using material science as a way to help sort of get towards that ideal, like circular economy, is something that's going to be like of relevance in the coming years. It's something that's quite close to my heart. So I'm interested in using materials from renewable resources. And of course, if we can, you know, avoid all this waste that's created from the sort of linear economy we're currently in and move towards systems where we can reuse or recycle materials more, that's something that I think we'll see a lot more of in the coming years. So, yeah.
That's great. Thanks, Fiona. And Sarah, what are you looking forward to?
Well, I'm going to certainly finish off with a theme then. One of the biggest things that sort of face our industry is understanding the way that the materials work so that you can have a full process from start to finish without having to worry about things like hindsight in the future. No one knew how successful plastics would be, so the fact that we have a waste problem with them wasn't really fathomed at the beginning. One of the biggest things that I'm looking into at the moment, and one of the research groups that I'm involved in as an industrial partner, is how to recycle 3D printing powder, and specifically looking at making really cool composite alloys like aluminium and carbon alloys. And at the moment looking at using, you know, things that are very, very readily available in the Earth's crust, we're not ever going to run out of them, and how we can use those with a waste product from an industry, and then how that can enroll into the world and actually make better materials from waste, which is really, really fun. And, you know, looking forward is, you know, all of these things in hindsight are all well and good, but maybe designing these things with recycling and, you know, sustainability in mind is kind of the most exciting thing I'll be doing this year at least. So that's all good.
Wonderful, thank you so much. So I think we've covered a lot of the questions that have come through our Q&A box. If we didn't get to it, we're really sorry, but send us an email and the contact details are in the Eventbrite that you signed up with, so we'll try to get those answered. And I'd just like to say like a big thank you to our panelists, so Fiona, Adrian, Mark, Belinda, Samuel, and Sarah for joining us today. I think you guys answered some really great questions and really gave us an insight into material science from A to Z, and so really appreciated. And I don't know, I learned a lot about what's going on in research these days, which is really cool. And so as a final thought before we wrap up, I just thought it's the very exciting time to announce our winners for our materials, Discover Materials infographic competition. We had lots of great submissions, and we judged these based on visual appeal, the content, and a range of sources provided. And we'd like to announce that the winners are Nirali Jain for their poster on indium tin oxide, and Stephanie Robertson for their poster on EVA foam. So congratulations. You're gonna, yay. Thank you for the claps from the panel. So those posters will be posted online on our website, which is discovermaterials.uk. And as a final wrap up, anyone who signed up via the Eventbrite page, you'll get a link to a feedback survey just to let us know what your thoughts were on the events and activities that we brought you this week. You can visit our website, which I've plugged about 1 million times, discovermaterials.uk. You can follow us on Twitter, which is Discover Materials, Discover Materials, and send through any questions via email at info@discovermaterials.uk. The email was sent in the chat quickly, just shortly ago. And if you want to find out where to study MSc in the UK, there's a map on the website which shows all the different UK universities that offer these programs for 2021 and the 22 academic year. And yeah, we just like to say a big thank you again to our panelists and to everyone from behind the scenes for helping with this week, and thank you for tuning in. And so I guess as the panels will all wave goodbye. Goodbye. Thanks again. And yeah, take care. See you later.